Welcome to Cpp.chat, a postmodern look at what's going on in the world of C++, chatting with guests from the community. But before we see how regular this week's guest is, John has a disclaimer to read.
Thank you, Phil. The Cpp.chat medical advisory team has developed or collected these protocols from practitioners and supplier partners to help healthcare practitioners make decisions when building treatment plans. By adding this protocol to your full script template library, you understand and accept that the recommendations in the protocol are for initial guidance and may not be appropriate for every patient. So with that understanding, I'd like to welcome Tony Van Eerd to the show. Hi, Tony. Is this your first time on Cpp.chat?
Yeah, it is. Thank you.
All right.
I mean, what took you so long?
Yeah, well, you know, I assume you've been on Cpp.cast, right? I think everybody thinks we just look at them to see who to invite on. That's not true at all. We make a list and then notice that they get to them first. It's not like we're copying. I swear we aren't.
They have spies, I guess.
That's right. Yeah, that's right. They're looking at our list. Those guys. Of course, they're doing it every week, so they get to people faster than we do. Anyway, so it's great to have you on. Have you been busy during this lockdown? I assume you've not been going to conferences.
Yeah, I haven't been going to conferences. Haven't been going anywhere. It means I'm writing more code than I usually write because. Yeah. I mean, for a while it was until people at work realized that they can still get in touch with me and ask me questions, and but that, I mean, that is part of my job. But yeah, I find that I'm writing more code now than I typically do, because half my job is not writing code; it's just reviewing code more than anything. Sure. So I've talked to mostly programmers, right? Because that's my circle. A lot of programmers are like, well, I'm an introvert anyhow. So they're all kind of, obviously it's a lot harder for a lot of other people. And I'm still working, I still have a paycheck and everything. So that makes it easy for me. So, yeah.
Yeah. I wish I was getting money. So there you go.
Yeah. When you're independent,
it's a whole different ball of wax. But actually, yeah, I was on a call recently with someone who was talking about people at their work who are senior people who are saying, I'm just so much more productive now. And it's like, because I'm not getting asked questions. It was like, you realize the people who aren't asking you questions are now less productive, right? Yeah. Because as you just said, it's part of your job to coach. That's part of what we do as senior engineers is we help those who are coming along. There's a lot of things you don't get in formal training. A lot of specific technical advice you can give, but also some kinds of coaching about this is how we do things. And things
I also think I get this feeling I'm probably working more hours than ever because the hours are kind of spread out, right? Like if I want to take a break, or if it's like, well, I should go out. It's nice outside now. I should go outside now and I'll work later, or I will, anything's going on, right? My kids need something. It's like, okay, well, it's very flexible now. But then I realize, okay, it's now 10 or 11 at night and I'm still coding. It's like, I probably made up for that hour in the middle of the day. Why am I still sitting here? But as a programmer, that's what you do, right? You're just like, I just want to fix this one problem. Just fix this one more line of code. And then it's 2 a.m. So
I totally know. When I get really involved in a problem, I can go for hours without even thinking about what the time is. It's just like, what's the next step? It's just it's what we do is we solve problems, and those problems are sometimes interesting. And sometimes even if the problem itself is not interesting, the solution is interesting. So you still get wrapped up in figuring out what you want to do. So what are we going to talk about today? I added a link to Tony tables in the show notes. This is your GitHub for CPP20 and Tony tables. You want to tell us what the heck Tony tables are?
It's a surprisingly controversial name. I didn't name them. It all started actually with a someone did a proposal for, I'm on the C++ committee. Someone had a proposal in the library evolution working group, and proposals are all written in a certain, like we have a template, you know, not a C++ template, a document template of how we suggest you write a proposal, and everyone follows the template. The template's bad. At least I think the template's bad. And it has like, oh, here's the motivation section, and here's a section to say, well, what are you changing and all this. But it always ends up, I read the whole thing and I'm like, okay, I kind of lost the point and I still don't know what this, and it got too technical too fast or something. And finally I just started saying, and I helped someone with the paper. I just said, all I gave them was a table showing, here's how you would have to write this code in whatever it was, C++ 14 or something. Here's how you had to write it in C++ 14, and with your new feature, you would write it this way in C++ 17. And I put them side by side, and it's before after table. And and obviously I'm not the first person to ever do a before and after table, but I really pushed it as the thing is that shows what you're trying to say. It shows the motivation, because hopefully the example that you show is a useful example. You say, oh, I see what you're trying to do. I see from the before how hard it was to do it, and now I see how it's easier. And I can now go look at the technical part of your class, but I see it in use. So I understand what your syntax is. I pretty much understand everything from one page. It's the one page summary of your proposal. And if I don't, and the real thing is that pretty much every proposal we ever do is about how the code will change, right? It's a language. I'm making a change to the language so I can code differently.
Sure.
So if you don't,
theoretically, there might be a proposal that says, let's change this so that implementations can be faster.
Yeah,
but that's not what most of them are about. Most of them are in fact about how you could write code.
Yeah, how the code's going to be different with this feature.
How you can make it clear.
So just show it. Just show me what the new code looks like.
I know it took me a while, as a beginning programmer, when I wanted to document something, I tended to shy away from doing specific examples because an example is inherently, that's just one case. I want the general case. I want to write a template in my documentation. I want to explain to you the entirety of what the problem is. Humans don't learn that way. Yeah. Humans learn by looking at examples. And so you need them both. You need to be able to specify what is the limit, because if somebody's writing a compiler or a library, they need to know what the edge case is. They need to know what they have to support. But humans learn faster with those examples.
This is
a concrete example.
This is my litmus test for developer. And I've talked about this to people before about how I don't think I interview developers the same way most people do, because I've had interviews where I don't think we talked about code at all. I mean, it depends what company I'm at. Certain companies have certain rules for how they do their interviews, but for me, I just talk to you, and I didn't realize a long time what exactly I was looking for. But one of the things definitely is you can go from specific example to general and back to specific and back to general. And it's like, okay, you think like a programmer, right? And the one that got me the most was on one of these trips to a conference or something. I'm in a taxi and I'm talking to the taxi driver, and we're talking about the weather and clouds and stuff like that. And he got really he knows clouds. This guy knew what he was talking about. And then he went very general on and he just spoke at every level. And my whole vibe for this, it was just from the airport to the hotel or whatever it was, maybe a 20-minute taxi ride. My whole vibe was, you are a programmer. Your brain works like a programmer does. And if I always feel I should have said something to him. It's like, maybe you like being a taxi driver, maybe you don't. If you don't, become a programmer, because he was definitely a programmer mindset. And not all programmers think the same way, and it wouldn't be good if we all did think the same way, but that was something where it's just, I find a good programmer needs to be able to, you need to be able to be very syntactically, very picky and very specific. And then you need to be very general and abstract. Otherwise your code's not going to, your code will, it's fine if you have someone who just likes to write very specific code, you put them in a corner and let them write specific code. But when you need something that's architectural and more abstract, then you need someone who thinks that way, right?
Right.
think both ways.
The ability to scale up and down in that sense, but also to scale in terms of, yeah, I sometimes talk to people, we try to avoid politics here, but sometimes talk to people about something and they say, well, there ought to be this. And I say, yeah, well, how would that scale? It's like, if that was really the law and everybody was behaving that way, how would that scale? And it's like, oh, well, that would solve this problem. Yeah, it would solve this problem, but it doesn't scale. And that's another thing programmers think about, is how does that scale? Yeah, you can do that when you only have a few items, but what happens when you have, how does it scale? And in fact, I don't know, did you see Dave Abraham's article on how to design a good library? Did you see that?
Oh, I don't know. That sounds.
We should put that in the show notes. What it's really focused on is thinking about how the user's code is going to look.
Right.
He doesn't talk about anything else. And in fact, he's actually, I think, probably thinking in terms of Swift when he's writing this. But the fact is, it certainly applies to C++ programmers. But he's really focusing on saying, one of the things he's saying is you really need to understand the domain, because you need to understand, and I think we had on, I shouldn't have mentioned this because I'm not going to remember his name, but we had somebody on who was talking about color. And remember, we were talking about how
James, not Burrows, but just recently, right?
Yes. Just a few episodes back. That's how bad my memory is.
Went to the committee for the first time.
Right. Yeah. But he was pointing out how badly most color libraries don't implement color because they don't really understand the domain. Anyway, that's the first thing Dave says. You really have to talk to people who are going to write this code. Imagine, you're writing mapping code and you don't talk to people who have actually done mapping and know something about mapping, or you're in your case working at Christie, you're talking about people who understand color, who understand projections and understand how light works. And you're just writing code thinking, well, it's just a formula, right? And so it doesn't really matter. So part of it is you really have to understand the domain. But the other thing is you have to think about, what does the code look like when someone calls this library? It may be convenient to write, but that's not enough. You need to make it so that when someone reads it, it's clear what they're reading. And so if you have this function and it has 2 parameters that are true and 1 parameter that's false.
And C++ gets knocked on this sometimes, where someone looks at the library you wrote and they're like, that's way too complicated. And you've got all these templates and you've got these enable ifs and you got all this stuff in there. Right. And they're like, this is gobbledygook and your library is terrible. And it's like, well, no, I did all this work on the library side so that the code you call is easier.
The code you write is easier to read. Yeah.
And it's like, if you call it, it's that the pit of success idea of, it's hard to call this incorrectly. If it compiles, it was probably right. And that takes a lot of extra effort on the library side. And sometimes I do it. And sometimes I think, yeah, I went overboard and I maybe went too far and I should just trust my fellow programmers to not make mistakes. But a good library sometimes looks ugly on the inside, looks beautiful on the outside.
Well, I think about the language overloading rules. I mean, Can you imagine anything more complicated than that? But the reason they're so complicated is so that it does what you want/expect most of the time. You can trip over them, but for the most part, the overloading rules do the right thing, and that's why they're so complicated. Yeah, and so it's better for the callers.
No one understands the overloading rules. That's a big problem. And I'm sure Richard does. That's the asterisk on. I always say that the concept of C++ expert. I always say there's no C++ expert. Oh, except Richard. Yeah. We just leave him out of the conversation.
We'd use that as a show title, but I think we've already done it.
Probably have. All right. So, what are the things we want to talk about? Are you planning to give a talk at CPPCon?
Well, that's what I was kind of asking about that. Poking you about CPPCon. I have this prediction that I will not be going into the States anytime soon. Not to get too political, but your country's on fire. and which, you know, it's terrible, and it's hard to think about, you know, coding at times like this.
Yeah.
But just COVID alone would probably mean I'm not going to go to anywhere.
Let's re-ask the question.
If
If you were going to be at CPPCon, what would you be talking about? How about that?
Yeah. Well, so no, but the other question is like, yeah, can I do something? Can I send you a lightning talk? You know, can I send you a video or something? You know, we'll see. Because there's, I don't know if you saw the JF did a presentation where he quoted me from a talk that I gave at CPPCon 20, right? He's quoting me in the future, saying that I will be quoting him in my talk. And so it's like, since then, I've been planning a talk to make sure that I can put the quote in there and that it'll all work out. And the quote is about you know, the people who forget the past are going to repeat it. And he's quoting me in the future and talking a quote about the past, and it's pretty good. So I did have this big plan to talk about solid, right? My talk title is called Solid Revisited, because whenever I hear about whenever someone brings up solid, I always think, oh, I don't like solid, and then I look at each of the letters of solid, and I'm like, oh yeah, that's good. That's a really good principle. And then it's like, well, why don't I like the whole thing put together? And it's mostly because it just, if you go look back, and because now I've started working on this talk. If you look back at the origins of solid, you know, it's all about change management, and you know, if you put your code this way and something changes, everything's gonna have to change. If you reorganize it a different way, the likelihood of change will be isolated, right? And it's somewhat because of, it's somewhat built into the solid principles, but somewhat also just how people have applied them. It's too object oriented, and there's good times to use object oriented, but it becomes a crutch of solid, and plus object oriented gets way overused. So yeah, I would like to do a talk on, like, well, it's called Solid Revisited, and it's like, how do you do value-oriented programming, and how do you still do solid, and what are the real key principles?
So something like solid for value semantics or something like that.
Yeah, and you know, of course, I keep thinking, oh, I need to make up a different acronym, right? So I don't know what it is yet, but I've got one other acronym, which is, you know, we all know KISS, but it's kind of a derogatory acronym, really. Keep it simple, stupid, which, you know, it's kind of putting people down. I have KYSS, keep your stuff separate. That is the only, and if you look at where solid came from, it's how do you keep your code separate from the rest of your code? That is the only, I think that's it. That's all there is to programming. Keep your stuff separate. And then it's like the details of, well, how do you do that? And it's like, well, there's 27,000 ways of doing it. You just got to pick the right one. Right?
You know, when I was, did freelance coding, and I'd drop in on projects. Yeah. The feature of a code base that I would like more than anything else, more than being well documented, who doesn't love well documented, is modular.
Yeah. Because
if it's modular, I can throw parts away. I can completely rewrite parts if they need to be rewritten. But, you know, when you land in a code base that is just a spaghetti mess, where anything you change, you're potentially breaking something and you have no idea. That's the nightmare. But if it's modular, even if it's not well documented, even if it's not clean code, even if it's not, you know, whatever other problems it has, you can work through those. But if it's this conglomeration, as you say, they didn't keep it separate.
Yeah.
Then
the weird part, though, is everybody knows that, and all code bases end up not that way, right? So it's like, how does this happen? And it's, you know, that's my mystery that I constantly, I don't have an answer, right? I have partial answers. There's partial answers of just like pressure of time, right? So I know if I just add this one more if statement right here, that'll fix that bug. It's like, well, you know, it doesn't belong there. And
Right.
to write that if statement, you need to pull data from 5 places, and it's this big giant if statement that says, okay, that's the condition we're in right now. It's like, yeah, it should have been somewhere else, but it does fix the bug. So that's.
But you've now tightly coupled this class with some underlying thing that it shouldn't know anything about because you didn't. Yeah, I mean, the way I think about that is, and it's almost a play on words, but I say think logically. And what I mean by that is not think rationally. What I mean by that is don't think about the code in terms of, oh, I need to set that member to this thing. No. Think about it as I need to prepare for printing. Yeah. So I make the call that says prepare for printing, which might be nothing. I don't have to do anything, but it might also be that's the time I change this member to this, right? Yeah. And that's what I'm trying to think. Think about it in terms of logically what's happening. And then when you do that, then you can say, no, this object shouldn't know anything about that.
Yeah. The whole idea too of like, I'm on top of my, the Tony tables in my GitHub, which I did it for 17. So if anyone wants to learn 17 versus 14, I've got a document that has just a Tony table for every major feature of C++17. Problem is C++20 is huge. So I've got like 3 examples so far for C++20 Tony table. So I'm way behind.
So maybe I've got the wrong link here because I've got the link to CPP20.
Yeah, there's a 17 and there's a 20, and it's all on my GitHub. But the 20, I mean, the link to 20 should be there to be like, I accept pull requests, because I think so far I've done less than the other contributors. But the other thing I'm doing,
has this had an impact on the committee? Are papers starting to come in with Tony tables built in now? Is it becoming part of the template?
There, every now and then, someone will just ask, "Where's the Tony table?" And once again, I think it wasn't me. I think it was David Sankel. I think is the first person who started calling them Tony tables just to poke at me.
David would never poke at
you. Yeah, I know. Yeah. And so it's, you got to be 15 minutes of fame for something, right? So, but yeah, because speaking of proposals, not every proposal is a change of the language. The other category of proposals are a change of the committee. And I'm thinking that's all I should write is meta proposals of like, here's what a committee paper. There's talk of writing a paper on Tony tables, and of course the paper would have a Tony table showing old style papers without Tony tables and new style papers with Tony tables.
Very postmodern.
Yeah. The also like inception of Tony tables.
Very meta. You're gonna have it in columns. So
yeah, exactly. I was trying to think of like what would be a good example paper, and I was thinking of proposing like GoTo or something that's already in the language, right? And just like, here's how that proposal should have looked like. Imagine we didn't have GoTo, and I would use it because what else are you going to use? You use GoTo as this example, and then have actually find a piece of code that looks better with a GoTo. It doesn't happen often, but you can find some example codes like this is kind of convoluted. Here it is with a GoTo. It's actually simpler, and just have it as here's the new template. Just stick your stuff in a template like that. But where was I going? The other thing on my GitHub is there's a repo there called Today, which is, I don't know, kind of like a blog or something. Whenever stuff happens at work, I try to write it down. Just in general terms of what did we learn today? In a code review, saw something. Hey, there's something that can be learned from this. And I'm struggling right now to write. I realized the other day that I had to write how to write a function, which is not a critique of my coworkers or anything that I needed to write this, but in general, right? Because you said the phrase of like prepare the printer. And it's like that's a function, and so often people don't make that a function. They just stick that code inside the other function that's doing the rest of the printing, right? And it's like, no, you wrote a comment that said / prepare the printer. It's like, what the function name is. You've solved the hard problem of naming it. Now just take all that code and put it in a function. And this is one of the things. I'm so far behind all the things I want to do. I want to write just page on how do you write a function, and it's not easy, right? It's like first question is, well, when do you write a function, right? And then how do you pass parameters, because there's so many different ways, and how do you, and now it's just recently now, as I didn't start using C++ 11 the day it came out. I had to wait a couple of years for your code base to move to it and everything. But once you get move semantics, well built into your code base, and you've got and kind of requires exceptions, makes it easier for you. But suddenly your functions can take parameters and return parameters, which you'd think functions could always do that, but no. In the past, if you wanted to return a vector, you passed in a reference to a vector. Now you just return a vector. Just don't worry about that. It's not getting copied. The move, it's all efficient.
Which was probably copy-lighted anyway, but
yeah. But now right? And there's a lot less worries, and so now you can write functions that actually act like functions, like mathematical functions almost. And actually, I should bring up the.
We had a guest on just who was it? We had on just recently said you should grep through all your code and look for step 1.
Hey, that's my phrase.
Yeah. Look for step 1. Well, maybe I heard that on Cpp.chat. Maybe it wasn't our guest.
It might have been.
Any place where you see step 1, that's an indication that someone should have taken that function and broken it down into smaller functions, right?
Yeah, and if you called that function name step 1, it would still be better than stuffing it in
in the bigger function,
giant function. The one that caught me the other day is Kevlin Henney had a quote of write the comments that the code cannot express. Right. And it's not just the code doesn't express, it's the code cannot express. Right. And I was doing a code review, and I just saw that on Twitter or somewhere. So, tell my employer that reading Twitter is valuable to our code base. So that I saw that, and then I was looking at our code review, and someone had we're trying to do autofocus on a. Can I say? Yeah, sure. Or I'll try to be vague. We're trying to do some autofocus stuff, and this function took a projector, and it says uses the camera to do autofocus on the projector. And then I'm like, well, why doesn't it take a camera? Like, the comment was really good because it wasn't clear that it uses a camera. But then I was like, well, wait a second. Why doesn't it take a camera as a function param? It's like, well, it doesn't because it's in a class that already owns the camera, right? So I was like, well, wait, take this function, pass it a projector, pass it a camera. Now this function is not inside any class anywhere. And you just know that's the only things it uses. It uses a camera and a projector, and it autofocuses. Great. That's and I told the guy, hey, it would have gone past the code review if I hadn't seen that Kevlin anything of like, you don't need this comment to explain this. It would have been clear. And now it went from just being a better comment to being a free function instead of a function tangled up with another class, right? So yeah, now the code is more separate because of a comment, right? Or if the recognizing that a comment wasn't necessary. So
right,
I was pretty happy about it.
No, that's
yeah. Also, for my employer, reading Twitter, twice now I fixed bugs in our code base by tweeting, because I've tweeted to the Visual Studio team, and to their credit, it was a bug that's fixed in the latest release, but I was a couple of releases behind. I said, "There's this weird bug I'm having," and Billy or somebody tweeted back saying, "Oh yeah, that's a compiler bug. Just pass this flag and it'll go away." Right? But I would have wasted days trying to find out what was going on. And then another one with some weird stuff going on with NVIDIA stuff. So I tweeted, and Bryce and people tweeted back to me saying, here's what's going on. And I think that one wasn't their fault. I think that was just we didn't understand how it was working. But it's like I tweet and I get answers, and saves our company time.
One thing that I've learned is that senior engineers are way, way more likely to find compiler bugs, but they're way, way less likely to assume the compiler has a bug in it. It's the junior programmers that say, wait a minute, the compiler's doing the wrong thing. This should work. No, no, you don't know what you're doing. And And then when you, as I said, you start to begin to realize, no, the compiler doesn't make these mistakes. And then when you actually run into a compiler bug, it's like, what's going on? Because you just can't believe the compiler's actually making the mistake.
And you sit there and you think, the last time I saw a compiler bug was 4 years ago. Right. Yeah, it's about time.
It's about time. Yeah, that's true.
Well, credit to the Visual Studio team. I used, old. I've been doing Microsoft compilers for a long time. I worked on I wrote apps for Windows 3.0, not only 3.1. So yeah, their compiler was used to crash a lot and do bad things and had tons of bugs, and now it's a joy. And their debugging on Visual Studio has always been a joy. So they're all between all the compiler vendors, there's so much more competition. But also, like, they all work together on standard libraries and on the committee, and I don't know. It's a good time for C++.
Yeah, it is. I think there really is a healthy competition.
Yeah.
There's no the kind of competition that we in the industry are definitely enjoying, because everybody's trying really hard to make their product better and do it in the right way. I know particularly Microsoft in the past had been, accused of lock-in kinds of things where it's like, oh, we're going to extend the standard and you'll start to use this feature, not realizing that it's going to lock you into Microsoft. They don't do anything like that. And I don't think the C++ team has really done that. But
yeah, I gotta say, does anyone remember Cairo? And not Cairo, the 2D graphics, Cairo, that was supposed to be Windows 4 or whatever. That was supposed to be a relational database file system, and there was that Cairo. And I was working at a place, and we had a image library thing, and our own image database and stuff. And we're like, we shouldn't continue this product because Microsoft's going to come out with this new database style file system in Cairo, Windows 4, blah blah blah. And then it just never happened. It was just like, we had all these great ideas, and they just died on the vine. It's like, so yeah, I lived through the bad Microsoft days, and for some reason now Microsoft seems like the good company out there. At least, well, let's not get political there either. Yeah. But they're not perfect, but it seems better than they used to be.
Yeah, there's this really healthy competition, as you said. It used to be that Microsoft was the laggard in terms of supporting the standard, and I don't think that's the case anymore. I think all the compilers are every time there's a committee meeting, it's not even wait till the standard's published. It's here's a committee meeting. Let's go home and implement this stuff.
They literally go back to the hotel room and start coding it so that the next day they can say, yeah, I've implemented that feature.
Yeah.
Which is really good when you vote on the feature, because it'll go through and you're like, okay, this feature is going to come to the committee at the end of the week and we'll do the final vote on it. But we all know it's coming up. It's probably going to get voted on. So you'll get a rush of implementers who can come back into that meeting and either say, yes, we've implemented, no problem, or no, we haven't implemented. We tried to implement it and we ran into this problem. And we're like, whoa, stop, because we thought this was, and of course, there's talk right now about some of the features that did get into 20 that weren't completely implemented before we said yes to them, and we're like, oh, that didn't work out quite as well. But
right.
Well, that's what defect reports are for and stuff. We'll figure it all out. But yeah, things get implemented the night that it gets voted, or the night before it gets voted in, just to make sure.
Well, I would hope that happens a lot less on the library side, but I know that that has not actually been the case. We look at a trivial thing like, oh, let's convert this double into a string, and we'll just say that we can do that somehow. And it turns out that's not as straightforward as you thought. And it really would have made sense if somebody had said, wait till we have an implementation before we put this in the standard. It's such a no-brainer, right? Yeah. Let's just take all the types and convert them to strings and just put that in the standard. And then, it turns out.
And the thing was that there was new, people had done some work on this, and it was like, it was kind of bleeding edge, I guess, that, to make it round trip and all this other stuff. And it's like, oh yeah, this is all possible. It's like, yeah, okay, but has one of the standard library writers written it to,
we don't need to do that. It's so straightforward. It's just No, it doesn't. We don't need an implementation on this feature because it's so simple and straightforward. And let's just get it in.
Yeah.
I am. Well,
I mean, I'm amazed at how well the committee does, given all the chaos of, the way, and kind of the way a committee with more than 200 people in it, and so many features going on at the same time, and all the stuff that happens. And sometimes you're looking at something and we only, we look at it for a few hours and make decisions and things like that. And it's like, it's kind of like having a lot of people with a lot of eyes means it does get seen, and someone catches things, and it works overall in the long run, right? There's always going to be problems.
I have great anxiety about this. I will grant you that we've been, I would say, lucky. There's some situations that haven't worked out so well, but I think that having a larger committee means that there's less of a concept that you should read every paper. I think there was a time, now it's been years since everybody read every paper. I'm not saying that, but when people stopped reading every paper, they at least read, well, I'm going to read all the papers in the library, or I'm going to read all the papers about this or something like that. And I think we're down to a situation where, well, I'm going to read all my papers, I'm going to read all my friends' papers, and I'm going to read these 3 papers that look interesting to me. And I'm going to sit there and vote on things in committee based on the presentation in committee. And that I don't like. And I think, as I say, I think we've been lucky. You say, a lot of eyes do see it, but very often we've looked at it in committee for, as you say, a few hours, and it goes into the standard. And I just think,
yeah. And we're right now trying to put in some more pieces of the process to be like, if something gets moved forward in one meeting, it's not. There's another stopgap there so that everyone knows this is being marked as ready for next meeting. Yeah. So if you can't read every paper, you should at least read the papers that we're flagging as, if you don't say something, this is going to go in, right? Yeah. So we're trying to, because we realize that when you get 200 papers every meeting, you can't read them all.
Yeah.
So
and I think, Bjarne has kind of pushed back on, maybe we get too many papers. The problem is nobody wants to be the person. I used to think, well, if we get more people in the committee, we have more eyes, more all this stuff. But what happens is you just got more people who think, oh, I should write a paper. Yeah. And in a sense, you should write a paper. But in another sense, we have enough papers.
Yep. And the people like Bjarne who, reasonably want to see all of it and make sure it all fits together well.
Yeah.
Right. And that is becoming harder and harder. How do you know this all fits together well? And so,
right.
Yeah, it's
part of it is, if you're on the committee, I mean, I know this because I listen to Cpp.chat and I'm on this show. And what do? We say, well, what proposals have you made in the committee? We never say, what proposals have you killed? Yeah. And that's probably more useful, right?
I have a list. Yeah. I don't know if I've killed a complete proposal, but I partially killed, I killed span equality. For better or worse. I don't know if it was a good decision or not. I'm partially to blame why we don't have optional references, which may or may not be a good thing.
Which, I mean, Boost, the Boost optional specifically designed, as said, we considered references and we rejected them because it's problematic.
No, Boost optional does have references.
Yeah. Oh, it does. I'm sorry. Okay.
Yeah, and that was a really tough thing too. It's like, we, on one hand, we don't want to just rubber stamp everything that comes through Boost, but we want stuff that has a lot of eyes on it already, right? We're supposed to standardize things that already exist, and Boost is the obvious place to look. C++11 was hard because so much changed. So, would you take all the Boost things that were written for pre-11? Oh no, we're going to make changes to them, right? They have to, what do they do for move semantics? What do they do in all these cases? And Boost also has this thing of a lot of libraries, the more useful there are, the harder it is for them to change. So if you look at a Boost library and say, well, was that the right decision? It's like, well, Boost kept with that decision. It's like, yeah, but was it the right decision, or they kept with it because they have their own backwards compatibility story, right? And so it's like you have to take a balance of, well, I want to look at Boost, learn from it, and then maybe we make some changes, maybe we don't, right? And it's
I think
a tough call.
I think one of the things, Michael has brought up in the chat, he's saying committee members were always pushing, you don't like it, write a paper, and encourage people to write papers. I think this is one of the things that Bryce has said a number of times, which is we told people, papers are welcome, and we need to start saying, wait a minute, enough on the papers. And I think there might be some truth to that. I think we need to think about, if you don't like what's in the standard, instead of saying write a paper, say, well, why don't you review some of the papers that are coming in and figure out what's wrong with them and what direction they need to go. Because I don't think anybody who's writing a paper is going to resent it if you take the time to review their paper. They're going to be appreciative, even if you say critical things, even if you say, hey, did you think about this? And maybe you should call it this, and here's an idea for this, or do it this way, right? They're still going to appreciate it because.
Do you know the best way to make that proposal? Write a paper.
Yeah. Well, no, I was thinking like maybe the bar is that you have to write 3 good review papers before you can write your own proposal. Like all you're allowed to do is review other papers for, it's the initial bar. And then once you've paid, because it used to be you have to give a kidney if you want to make a library change or a language change. Library changes are slightly less costly, but
if you want to add a key.
Yeah. But it should be now. It's you have to do a couple of years of reviewing and killing other, or improving other papers before you write one or something like that. Which is not really the right thing either, but somehow encouraging. We've got too much work to do. It's true.
There's a discussion between Robert and Renee saying, as Renee says, the committee needs to stop thinking they provide the entire C++ ecosystem.
Oh, yeah. I mean, our biggest issue is not having a package manager. That would not only help decide what should go in the standard, or like have things that never go in the standard because, you can just get the package. But also, like Boost, things would bubble up. Yeah. Right? Things would bubble up. Everyone does 2-string this way now. It's like, okay, well, let's standardize that one because it's de facto standard. So we don't have a lot of places to find de facto standard. We've got Boost and we've got like GitHub stars or something. It's not enough to, format is a good example of, hopefully a good example. We'll see how it turns out, of a library that just seems like if this was good, lots of people are using it. Well, let's standardize it, right? Yeah. And it feels like one of those things that, being able to print out stuff well is something that should be in the standard, and both printf and
3 options for how to do it is ideal.
Insert xkcd. I should know the number of that. Yeah.
But I mean, I know that that there's a major library added to 20 that. There was a lot of effort put into getting this ready to go into the library, and it didn't, there wasn't time to send it through Boost because it was based on concepts, which is a new feature in the language. So there isn't time. And I'm thinking that should have been the red flag right there. If you're saying it's based on a new language feature and we got to get it in the library, I'm thinking, no. Based on a new language feature means we should spend some time to make sure it's right. I'm optimistic. I hope it's great. Lots of cool functionality and all this kind of stuff, but it was rushed, and little user experience with it. We have a tradition of the first version of STL was miraculous gift from Stepanov, and it was rushed into the standard as well. And so now we have a rewrite into a certain extent of the STL, and we're just going to hope it works as well. And we've rushed that. So it's
not like it's a high bar to match Stepanov or anything. So
that's right.
Just an iterative improvement.
If you watch his lectures, which because I worked at A9, I got to do that, but they're on YouTube. People want to watch it. He's the first person to point out, oh no, we specified max wrong. Yeah. We got this wrong. We got this wrong. The name of vector, he claims vector was a mistake. He doesn't really have a better name, but he said, I was told this kind of container should be called vector. And And clearly, we stepped on our own ability now to have vectors and matrices.
Especially when he's such a mathematician, right?
Yeah.
And so how did you name this vector?
From the beginning.
The other one is I like to bring up is standard copy is you pass the source and then the destination is the order of the arguments. And and Stepanov says that was also wrong. It should have been the same as memcopy and strcpy, because C and C++, like assignment works right to left, right? You assign that way. But he said when he originally did it, he was thinking mathematics. You say F X to Y, like the arrow for goes from domain to range, whatever, range, domain, math symbolism. So he did it right, left to right. He should have done it right to left. And people are like, well, where did he say that? And I'm like, personal correspondence. Because he was at Adobe and I was at Adobe, so I didn't get to talk to him too often. But I remember I asked him about that one. He's like, "Yep, that was one of his mistakes." So I always tell people, like, Stepanov made 3 mistakes, and I try to list them, and I know that there's 4. And that's why I always say there's 3, because off by 1 jokes. And I can never remember 4, but I think it's pretty good if he's got 4 mistakes, and it's like the one about min and max is so minor, and order, they're all minor. They're all tiny.
Sure. I mean, we would have. Yeah. He also says partition is wrong. We want to, when we sort ascending. So partition should have all the falses before all the trues.
Right.
And that's the reason it should be that way. And it's because partition is essentially a sub-step of doing sorting, and so it should work the way sorting should do. And so, but you can see why someone specifying partition without having any sense of context is going to say, well, yeah, we'll do all the ones true before all the ones false.
Yeah. And in calling STL rushed, it was rushed into the standard, but like Alex had worked on it in multiple languages, right? He had spent years and years honing, this whole set of concepts and library.
So one thing I'll say though, I was surprised with this. So before 11 shipped, when the consensus for concepts had broken down, after it went in and it was voted out, Alex hosted at A9 in Palo Alto, hosted a group of people from Indiana and also from College Station to come and talk about concepts, because there were these 2 competing proposals and they couldn't see eye to eye. And so Alex was going to make, Alex was not a big fan of the committee or the committee process or any of that stuff. But this is what he was trying to do is, and so Bjarne was there and players on the concept side. And because I worked at A9, I mean, I had no, I should not have been in the room by any other reason except I was in the room for that. We did that for the entire week and we worked on that. But one of the things that we worked on, or what we worked on mostly, was specifying the concepts that were behind the STL. And frankly, I was shocked that hadn't already been done. I was kind of surprised by that. If you read Matt Ostern's book and, the books, even Alex's books on how to do generic programming, you create a concept and, and yet they really hadn't defined in great detail what these concepts were. They just kind of had, well, forward iterators a concept. Well, what exactly does that mean? I was surprised myself that, it was, I don't remember what year this was. It was not, 11 hadn't shipped yet, but it was late in that cycle. And we were sitting down and saying, okay, exactly what does it mean, to be a forward iterator and an output iterator and these kinds of things, and really formally defining them. And frankly, I never said that then because I think it would have been kind of embarrassing, but it's like, we're just now getting around to defining these concepts. Yeah. Really?
Yeah, and I think the part of that was like everyone had vague concepts in their head of what a forward iterator is and stuff like that. And then if you try to define exactly what it is in the standard, you realize that a lot of things that are claimed to be a certain thing aren't, right? Same with if you look at all the container requirements and you go, which of the containers actually satisfy all these requirements? And you're like, maybe none of them. But they all almost do, or like in some way they do. And And
Well,
it's kind of
it's
like it's the engineering trade-off, right? At some point, we just went
specify
practical.
in the standard, these are what a container does. I think even STD array doesn't satisfy them because you can't delete or add things to the array. So it's not really a container. And yet it's like, well, what is it if it's not a container?
Yeah.
But I lost the thought of the other point I was going to make about
just the concepts in general.
Oh no, what I was going to say is concepts regular.
Yeah.
If you look at what Alex did, was he said there's something called a semi-regular type. A semi-regular type is a type that is in all ways regular, except it doesn't support less than comparisons.
Right.
And but I don't think that's in the standard. I think the standard just has the concept of a regular type. And so if we can't even decide what's the definition of a regular type, we can't all get on the same page about that.
Well, basically what the standard did was they threw out less than. Regular doesn't have less than in it, whereas Stepanov's regular does have less than in it, which I kind of agree with that one too. My example is, I'm sitting on a chair, right? I've got my chair class that has number of legs on the chair and the color of the chair and all these properties of what a chair is. Less than one chair being less than the other chair doesn't make a lot of sense. Right?
I think part of it is that, Stefanov was really focusing on the algorithms.
Yeah.
And you really want to be able to compare if you're doing sorting there's just so many things you can do. And one of the things in retrospect, if we were to go back, we would say the default sort shouldn't be less. The default sort should be whatever the default sort is.
It should be called default sort or something.
Yeah. And then you can define that to be less for types that want that. But that way you can do for like complex numbers, you can have a natural ordering for it without saying, well, that's actually less than. Because less than doesn't make sense for complex numbers, but it certainly makes sense to sort everything based on the real component followed by the imaginary component. And at least you have a predictable
exactly
sort order.
But if all your Tony chairs are around a Tony table, how are you going to compare them?
The dining philosopher problem. That's the first thing.
But the author of the class can decide. Well, when you're comparing chairs, you do it by weight, or you do it by cost, or you do it by.
Well, you offer up 5 different sort criterias and use the one you want for the occasion. And if you put on your math brain, that means it's like you take your elements and your operations, and then you form a group or a whatever other, magma, something, all these math terms of like, is this a quotient ring? Is this a whatever? But that is elements combined with operations. And to a certain extent, you don't always want to combine all the operations into your type. Your type can be sorted 5 different ways. One might be more natural than the rest. You want to make it part of your type, or none of them are natural, so they're not part of your type. They're just free functions, right? Mm-hmm. And that's that same idea of, comes full circle to like, keep your code separate. Like, how many functions should be on standard string? It has over 200 member functions, and there's no limit to the number of function you could add, things you can do to a string. That's a long list. Right? So at some point you got to draw the line and say, well, these ones are really kind of useful. It's not even just, you can draw the line at these are the minimum set with these 3 functions. I can do everything I want to do with a string. It's like, well, that's probably too minimal. At least make it ergonomic in some way, but we don't need 200 functions. And that's the art half of defining a class. What is the essence of this class, and what should be separated from the class. I just did that recently in our own code base. We have an image class, which I've been rehabilitating over the last year or 2, and it's become a move-only class and some nice things. But it had a bunch of functions in them, and I've taken almost every function out because it's like, it's an image, it holds pixels, right? That's what it does. It can, if you want to convert it, well, you just walk over the pixels and convert, and here's a bunch of image utilities that work on images, but they don't all have to be. And the one that always gets me is when people put the like load and save, like save this image to file. That is not a member function, because when that becomes a member function, that means you've just pulled in libping and libjpeg and the whole world. And it's like, I don't, an image class shouldn't even know there's a file system. It holds pixels. That's its job, right?
Right.
Keep your stuff separate.
Although you could add you could add a function to it called export, which gives you what you need to do the image part of do a save, or an import, which is the image part of the load, and then
factor it out somehow.
It's also possible that you don't need it because you already have tools to iterate across your images, your pixels anyway, which is all you really need. Yeah.
Yep, exactly.
So were there other things we wanted to talk about, like postmodern C++, or is it too late to get started on that talk?
Yeah, I don't know. It's we're
too late in the show, or too late in Tony's career?
Yeah. I had one thing the other, I've given that talk. It's the almost the only talk I've given more than once. It's definitely the only talk I've given 3 times.
Well, wait a minute. Let's step back, because people don't necessarily know what talk you're talking about. So,
sure. I did a talk called Postmodern C++, which I did at Cpp.con, or so first I did at C++ Now, and it was mostly tailored around tweets and nonsense, and somehow it's a critique of how to code. And then, because I don't like doing talks more than once, people really liked it and said you should do it again at CPP.con. And I'm like, okay, I'll do it again. And now I've got from May to September to work on the talk, because I don't like doing the same talk twice. And somewhere around there, I decided that I should rhyme the talk like Dr. Seuss. It was either Dr. Seuss or Shakespeare, and I was actually going to do both. And I thought, well, that would be really crazy. So I did Dr. Seuss. It turns out to be easier. And a lot of people liked the talk, and a lot of people were very turned off because I'm rhyming everything, and it's really hard to understand when you rhyme everything. And I since did it one more time on request from Hannah at her meetup in Prague.
And all 3 of these, by the way, are on YouTube.
Yeah. And you have to watch all
sources.
3. You can't just watch one. You have to watch them all.
Yeah, that's right. You have to watch them.
Because I change it every time. But afterwards, Timur was talking to me. He said, he's like, I don't want, this is not an insult to say he doesn't understand humor. He will walk up to you and say, I don't understand humor, right? I know that Phil has had this conversation with him. He doesn't understand all the puns and everything. But he said, my talk in particular, he's like, I don't get any of the humor. Right? So then we spent a lot of time explaining humor in a non-humorous way, right? And then I started realizing that the reason I use humor in my talk there is because, and someone just brought it up in Twitter just like 2 days ago, saying how it's like a unexpected something, and I'm like, yes, that's the point of the talk. Is he said unexpected ways of thinking, and I'm like, yeah, that's how you have to code. Like when someone's telling a joke, something unexpected is going to happen, and you tend to have your mind open a little wider, because it's not going to be the obvious answer. It's going to be something a little outside the box, and then you're like, and then you wait, and then it happens, and you get the, you weren't really afraid because it was just a joke, and then you get that satisfaction of, okay, I see how it all comes together. That's how you should write code, and that's how you should read code, right? You look at code and you're like, what's going on in this code? And you got to keep a more broad, open mind. And I find when people code, especially when you like, I need to fix this bug, you've got a really closed mind, right? You're just like, I need to fix this bug. I'm going to walk the code as if this is the only path the code ever takes. Right. And I'm going to put the if statement where I need to put the if statement. Okay, the bug is fixed. And it's like, that's not how you write code. You have to, think more broadly. And my whole talk, I didn't realize this till after the 3rd time I gave the talk, that, one of the points is this state of confusion that you should be in while you watch my talk is the state of confusion you should be in while you code. And it's, you got to get comfortable with that state of, I don't know everything, and keep your mind open, kind of thing. So that's the insight for the day on that. And next time I give the talk, it'll be a different insight, hopefully, because every time I do it, I don't know what my talk's about yet. So every time I do it, I gain new insights as to it is one of my, well, it is a very unusual talk. So, if you don't like unusual, I do talks on lock-free programming. They're very, here's how to do lock-free programming, but those are more dangerous.
No. Your talks are on how not to do lock-free programming.
Yes, that is true. They're much more dangerous. You shouldn't do it. Really, we should all just give up coding in general.
That's right. Yes, that's right. The only bug-free code is obsolete code.
Yeah.
Once there are no users, there are no bugs.
I have this other thing of like good code, and it's so strange. I spend so much time thinking about, well, what is good code really, right? And you get all these things of, it's maintainable and readable and all these things. And I'm like, well,
and modular.
Yeah. If that might be the only thing, right? But all those things all have, those are only important if you're going to change the code, right? Because we make an assumption that it's, but if every now and then you write throwaway code, and it also says that the first criteria of code is that it has to work, right? So code must work, and then you must be able to change it, and which really is good code causes other good code to be written, right? It's a self-fulfilling thing, and I mean bad code causes other bad code to be written in the same way that. Yeah. This code is hard. I'm going to make mistakes trying to use it. But code that begets good code and code that and that happens to also work. That's the only two.
Well, one of the things that Marshall Clough has asked me a number of times is, what would you rather have? Would you rather have code that's very clear, that has a bug in it, or code that you can't understand at all but doesn't have any obvious bugs? And the idea is, if the code is clear, I can identify the bug and fix it, and then I've got something. Yeah. But of course, the assumption is from the beginning that it's going to be changed, because it's absolutely true. No, it's completely flawless. There's no bugs in there. I don't understand how it works. I can't change it, but as long as it's flawless, that's fine. The thing is, if it were really flawless, if there was no intent to change it ever, it wouldn't be code. It would be binary, right?
Yeah.
You have code because you think at some point you'd like to be able to change it, and that's what good code is. Code that supports.
Well, you may have the code so you can recompile it for a different architecture.
Yeah, every now and then
But when you do that, you're going to find out that you've now got a bug in it. That it worked fine in the old architecture because it relied on undefined behavior, but it was okay on that architecture. But now,
but I think this very idea is very theoretical, because all code will change.
Yeah.
Unless it's no longer useful.
Well, you know what the scary part is I've got code that's 30 years old that hasn't changed at previous companies I worked at, and I'm like, you guys are still using that code? Like, what? How does that still just work? And I'm like, I guess I wrote good code at one point, because it's just, it's not good code in the sense that people maintained it and changed it. It's good code because it just kept working. It did the thing it needed to do, and things around it changed enough, and it was modular enough. Something I realized early, that I naturally wrote modular code. I don't know why. It's not something I learned. It's just, I think it's my math background. And that code, the overall structure of the code lasted for 30 years. And things did change, and certain parts of it just never needed to change. And because it works. And I was like, yeah. And I still think of are you sure? Because I was a junior developer then, and I didn't know what I was doing. Yeah, it's fine. It still works. All right.
Yeah, I at the beginning of the lockdown coincided with a project that I had done, not in C++, not even a professional project. It was it's actually the website for my book club, which due to some issues, I no longer actually attend. I'm kind of a virtual member, if you will. So I'm not really there, but I maintain the website. And the website has essentially gone without needing anything at all for literally years.
No, it's still got blinking text.
Probably a decade. But what happened is right before the lockdown, I got a message from the secretary of the club. It says, "Hey, the website's not working." I started looking into it, and it turns out that Python 2 support has just gone away.
Yep.
So the ISP forced everything into Python 3, and of course, this was written a long time ago. and it just doesn't work under 3. It just crashes in every way you can imagine. Actually, it doesn't crash in every way. It crashes in one way. And I spent about 2 weeks, and it turned out, because it's a book club, when you type in an ISBN number or paste in an ISBN number, it goes to Amazon and it pulls all this information about the book, it pulls the image out, all this kind of cool stuff. It's really great. But Amazon has just retired the API that was using. They now want you to use a new. So basically I spent about 2 weeks, pure technical debt on this code that was fine until it wasn't anymore. I mean, there's no code that eventually it'll have to be changed, right?
Have you seen there's a video on YouTube where the title, the video is the title of this video is how many views it has, right? The title of the video changes.
Oh, cool.
Constantly, not constantly, but
yeah.
continually, based on the number of views it has. And then the whole video is the guy explaining how you do this, right? And I mean, the crux of it is, well, he's got a server somewhere that keeps an eye on it and just constantly checks the number and updates but he's using APIs. And he's talked about all the other APIs he's done and the whole idea of Web 2.0, where it was going to be all APIs everywhere. And your thing could talk to the other thing and it all just work. And he's like, it doesn't stay working. And he said, one day this video will stop updating its title.
Yeah.
Because YouTube will change the API and I might be too lazy to go and fix it. So it's like, but it's kind of a weird video because you go there and it's got, the title is how many views it has. You first see it, it's like, how does this work? But
well, I'm actually in a situation. Have you ever heard of, it's called Dry Scrape? No. So for some of the utilities that I use for the conference, I actually do screen scraping on EasyChair. Screen scraping, for people who don't know, is basically you download the HTML and you search through the HTML, the way a human would see it. The problem is websites that are JavaScript based, you can't download the HTML. You have to download the post JavaScript HTML. And Beautiful Soup, which is this cool library for Python, just doesn't do that. You have to use Dry Scrape. I think it's called Dry Scrape. And this recently broke on the Mac. And I'm not sure, I've been Googling and I can't find anybody who seems to be able to install it. It doesn't install unless you make this one little tweak. And if you make that one little tweak, it will install, but then it won't run. I don't know what to do about it. But it's exactly what you've said. The change they made, the problem is they made a change on the Mac OS that somehow uses something different. I don't know what the deal is, but it's just broken. And I'm really frustrated because this is functionality that I kind of relied on, and I have to, it's really painful now. Don't know how to do it.
It's not like you're screen scraping to get like NHL scores so you can do your own website. It's like, no, you're screen scraping the thing that you're supposed to be using, right? Like
yeah. It's because the website doesn't have a decent API. Most of the web services we use actually do have some APIs, so we do them through the APIs. But this one, I have to do the screen scrape. Anyway, we're well
easy and
over
EasyChair is just out of spite.
Yeah, that's right. That's right.
Yes,
I think we're well over time. And I appreciate people who have stuck with us the whole time. Anyway, we should wish everyone safe coding. So if you can join me on that, I want to wish all of our audience safe coding.
Safe coding.
Safe coding.